Monday. We are all back in the office. We're on the shop floor. Hopefully, you're at lunch right now, hanging out, enjoying a sandwich or two, drinking a nice cold soda as we kick off yet again our Milling Monday series, where we are taking a much deeper dive inside of Fusion to the individual categories of toolpaths, some scenarios as we go, and then lastly, we will be wrapping this all up, of course, at some point with each toolpath, all the ins and outs, the tips, the tricks, and even the post-processing at the end. So today's subject is going to be about the fact we are talking about the heights tab inside of our toolpath. Now, if you are new here and this is your very first video that you're catching with us here at CAD Cam, I am Fusion Phil. Now, as most of you that show up that are reoccurring according to the status, you guys know me world renowned, but I'm going to do this as normal. Bogdan, one of our super fans, already in chat saying hi. But we're going to kick this off with no further ado. So let's get into this. I'm going to start my screen share. And as always, guys, if you're looking to use the models that I use for these demonstrations, they are all kept inside of the cam samples area. So go ahead and open your data panel with the old checkerboard here at the top, and then hit the home button so you can get to the top level scrolling down. So let's go ahead and pivot to a little different part so that we could start this off. But if you've missed any of our series so far, we've started with setup, and then we pivoted to tools. And then last week we were talking about inside of our toolpaths, the geometry tab. Now, rules are rules and rules. The rules that we like to enforce is, first and foremost, rule number one is left to right, top to bottom. And that's what we're going to use as we work through our toolpath menus. So the simplest toolpath to start with to understand the heights tab, in my opinion, is going to be nothing more than a 2D face toolpath. So what I'm going to do here is we're going to go ahead and define our tool. So I'm going to pull a face mill in this case. From that face mill, as we've talked about, we're going to skip the multi-axis tab for the most part right now. Now, a little bit later in this video, we will talk more on it. However, for most of you out there starting your adventure inside of Fusion, you're looking to do things based on 3-axis milling. Now, we did talk about our geometry tab. Again, that's our third tab in. If you guys pull that menu out a little bit, you'll notice is eventually we should get the names of the different tabs. I might have to go a little bit further, or in typical fashion, we always have some type of hiccup. But that cube boxes that you see gray and blue is geometry. We're going to jump into the heights tab. Now, this is one of the rare occurrences that we say for the top to bottom rule, right? It's a little easier to understand the heights tab from the bottom up when you're first getting started. Now, the reason why I say that is if we go all the way down to the bottom, or if we actually look at any of these, you're going to notice by default, we have what's called from, and then we have an additional offset. I apologize, guys. Every time I start these videos, all of a sudden I get an itch or a cough. But as you guys can see, we're going to have a from and an offset. Now, what that from means is what is it that we're referencing? And in this case, our absolute bottom location for this toolpath right now is from model top. Again, this is a facing toolpath. I'm going to get zoomed in here a little bit. As you guys can see, these are also color coded. So as you can see blue down here at the bottom, that is your bottom. Now, this is a personal request to Autodesk, is it would be nice if the menus on the right had some type of color coding as well. But as you can see, that blue rectangle on my part right now, dark blue nonetheless, is my bottom location. Now, it is giving me a dimension here, and that dimension is coming from my WCS. So right now we're minus 120 thou and some change. So again, our absolute bottom height is going to be the model top. Now we want to start our toolpath from the top height. So we want to work from top to bottom. This is where we are going to start from a stock top position. Again, this is a facing toolpath. We're looking to deck off basically the entire block. Moving a little bit higher than there, we have things like our feed height. So again, this is where we're going to wrap it down to more or less. Now, actually, I take that back. We're going to rapid to our retract height in most cases, and then we're going to go down to our feed height, and then from our feed height, go to our top height and work in our part. We'll see this a minute here once I calculate out the toolpath. And then lastly, you have your clearance height. So the cool thing is, again, I apologize, guys. I don't know what it is. It's probably this massive beard on my face that I'll get an itch in the nose. It's also really dry in our part right now. But again, you lastly have your clearance height. And the clearance height is nice if you have to jump over clamps and stuff. Again, we have retract heights based on drilling is a little more serious scenario where we need to retract to a certain location. And with that, I'm going to go ahead and hit OK. So one thing I want you guys to notice is I am not changing anything by default. This is what always takes me to rule number 2, which is when in doubt, hit the OK button. But as you can see now on my part file, my blue lines here, go ahead and I'm going to make a change to my setup so we don't have to see our fixture. And this should be a little bit more easier to see in the background out there. Let me know in chat if you guys can't see it. It's very small on my opposite screen. But as you're seeing, my blue lines are going based on my geometry we talked about last week. It identifies the stock from our setup. And then if I look at my part from the side profile, you'll notice those blue lines are going all the way across to the model top at the most, right? So again, my bottom height being model top. If I needed to change that for some reason, we can always manipulate that in our heights tab. Let's say, for example, I want to leave 10 thou material on there. Now, by typing in that 10 thou, you'll notice before I hit OK, you have my light blue toolpath line versus my dark blue, which is my actual true bottom height. So we're going to go ahead and hit OK again. And as you guys can see, we've now moved our facing up 10 thou. So again, as you're going to notice, is when we are defining things in our height tab, we always have the ability to override an offset from either a feature or a specific location. So let's look at something a little different the second time through. So again, one of the moves we did on this part when we were working on it last week is we are going to rough out this pocket here. So again, I'm going to go 2D adaptive clearing. I am going to change tools here. And then my geometry will need to be defined. And then as we're going to look in our heights tab, you're going to notice there's a couple less menus, right? So we no longer have, in this case, our feed height. That has been removed from the list. But again, we could work from our bottom up. So this time we're not going to model top. We are going to a specific selected contour. And that contour is what we drove from our geometry tab. Now, this is very important to remember because now our top height in this case, we're still coming from stock top. Not a big deal in 2D. However, when we talk about our passes tab next week, your depths or step down will be calculated based on your top height and bottom height. So in some cases, it's very wise here to actually say, I faced off this part. I may want my top height to start at model top. Now, you guys are going to see more examples of this as we move on, but I just wanted to, again, express the fact that notice how I'm not changing anything here. I'm making minimal changes based on what I know, right? I've already faced off to model top. Now I need to work from the top, which is from model top, which is my top height. And we are going to go down to my selected contour, which is my bottom height. So what you're going to see is this is going to calculate out real quick. Now, again, demonstration purposes only here is I want you guys to take a look. Again, if I had multiple depths turned on, and let's just say we're going to do a 0.2 step down. Now I have those multiple step downs across my part profile. So again, this works very easily in the world of the heights tab to be able to control how far we're going and where we are coming from, right? So let's go ahead and now hit one of these pockets here. So again, I'm going to go adaptive clearing one more time. You guys are going to see me do this relatively quick. We're going to go ahead and pick this open area here. Paul, great to see you out there. My heights tab again, we are working from stock top in this case to selected contours. So let's do my favorite thing with rule number 2 and OK our way out. Now, a few things you're going to notice is we now have the red and yellow lines in play, but those are good demonstrations of what's happening in some of our other heights menus. So again, if I orientate my part to the side, this is, again, one of my favorite things about Fusion is, if you notice, we now have that green line across here, which that green line references the retract height. Again, if you guys don't know what those are, if you tilt a little bit here, you'll notice in the color green, that is our retract height. So all of my toolpaths are retracting up to that green line right now. Again, those are all determined based on our stock top. Now, from that, we also have the ability to look at a clearance, which is our retract height. So now that's going down one level because these are tied together or chained together. I like to say daisy chain. If you don't know what a daisy chain is, it's when your truck is stuck in the mud and you got to use 3 or 4 trucks linked together to make it happen. But as you're seeing is we're now going to go 400 above stock top plus 200. And that's where you're seeing where we're starting in red and ending in that green arrow on our toolpath. Again, the idea is these clearance heights can be used to jump over features at the end of the day. But let's go ahead, before we clean this up too much, what I'm going to do is I'm actually going to turn on multiple depths again. We're not diving too deep into this, but I want to build scenarios that you guys will see visually to understand why we are controlling things in our heights tab. So right now, some of you are probably questioning why we're wasting a bunch of cycle time if we've already done a toolpath to knock out that area, right? So what's happening here is when we went in and turned on multiple depths, I know guys, as I said, left to right, top to bottom, we're just building out a scenario, is the visual element that is happening is why we're able to troubleshoot our own problems. But as you're going to see now is, well, my top height, remember we faced from stock to model, right? Well, then we went from model top to a selected contour. Well, in this case, I am now going to go from selected surface to our selected contour. So again, I can either pick a surface or I can pick a point or an edge. So I'm going to pick this floor now. So again, we're going to machine from the selected surface down to my selected floor location, which is the edges that we picked in the geometry tab. And just like that, you're now going to notice as my multiple depths have been trimmed up and we're jumping up and over as you're seeing. So I see a question already from Paul. Why not use the face off tool to clear the area on the left side? You're 100% correct at the end of the day. You could stick with that 2-inch tool if you wanted and go ahead and remove the material here by all means. So again, is depending on what your workflow is or what you're using, I just think from a visual standpoint, the adaptive clearing makes a little bit more sense. Now, if you want to see how you would do that, feel free to join us on Friday for our free support Friday, and I'll go ahead and apply those 2 things to this part. Now, again, the key element here is we're talking about the heights tab. Notice by dropping my Z height, right? So again, we go into our heights tab. We've changed our top reference, which has now brought down where our helical entry has began on this part. Now, again, this is where if you're really looking to save some cycle time, is I could also change my retract height if need be. Now, this is a personal preference. You guys tell me what you guys want to do at the end of the day. But if I changed this to either a selected surface at the end of the day, or I could even go as far as tying retract to top height by selecting top height. We'll hit OK and we'll recalculate. And now you'll see my yellow lines have been lowered. However, I still have my other green line, which is not referencing necessarily the top of my model. This can hurt you. This could cause a lot of good and a lot of bad. And I'm going to show you guys why. Is if I was to try and machine multiple areas at the same time. So give me a quick second here, guys. You'll notice that, oh, let's go back and take a look here. We gave it multiple regions. We should be machining both sides. But of course, what's now haunting me, which leads me into a really good valuable item here, is that my top height reference is below this floor over here when they made this model. So we're demonstration purposes only. We're just going to raise her up a little bit so I can get a toolpath on both sides. But what I want you guys to pay attention to is, again, we are retracting to a specific height on both sides here, right? However, we are clearancing now through our part. This is why out of the box, you should not be messing with your heights tab unless you absolutely know what you're doing, which is probably why you're watching this video too, is because you're learning a bunch of things. Now, you guys will hear me clown on Mastercam. I love Mastercam. I've used it for years. The joke back in the day on like X3, we used to call it Master Crash, right? Like, because there was a lot of issues with not having models, using wireframes, you can proceed to cause your own problems inside of Fusion. Now, if I went back into this toolpath, and again, remember, clearance looks at retract, retract looks at top. I may actually want to say, you know what, my clearance really needs to look at my stock top. And as you can see, again, visually, that orange line has jumped all the way back up to the top of my part. And now you'll notice is when we have to go from one area to another area, as simple as it can be, we are now jumping up, over, and back down. So again, very valuable at the end of the day to know, and when you simulate stuff like this, what your actual toolpath is going to do. I'm going to throw a couple more regions in here real quick. Again, what you're going to notice is every time we are moving from one area to another, we are going all the way up to our clearance height before coming back down to machine some other things. So what is this looking like for you guys out there? Are you liking this? Are you understanding where we're going with this? Again, for demonstration purposes, I want you guys to know I did raise my top height so that we could get a toolpath on the island over here on the right. There were hacks for Mastercam way back in the day, right? So again, let's go ahead and shift gears here a little bit. So as you guys have seen, I'm going to go ahead and remove this toolpath because we've done a lot of bad to it. I'm just going to recreate down here in the floor. Again, I could set a top height manually. And from that, we would have our toolpath. And again, some of you are probably questioning all these rapid retracts and motions. There's additional things in Fusion to fix those. The whole goal here is to show you how your heights tab, again, how to prevent problems in your height tab, as well where you're noticing all these heights are coming from and how to organize your stuff. Now, I would recommend, and now this is nothing bad against video content out there, I've seen a lot of people change their default settings in the heights tab. And what they use is they use their origin versus specifics on the part. Why this is dangerous is if your work offset is below your model, you will crash into your part. Now, for a lot of you, you could simply change this back by clicking the three little dots on the right. I would reset the system defaults, and then I would click them a second time and save as a user default. This is very, very important. Again, I've seen this a lot where why did this tool run through my part? And well, we failed to keep our default settings. So would I, Scott, in this case, Scott, I would not. And the reason for that is because I don't want to get too much into these other tabs because we're going to talk about this more later on. But if I jump over to my linking tab, you have the ability to stay down the most. Again, each toolpath has its own way. And now if you notice, I'm no longer making retract moves at all. I'm only making that clearance move to get over to my other pocket and region. So let's shift it up a little bit. Let's change gears here. I know I did this with a 2D toolpath, but as you guys will notice is any kind of toolpath you pick inside of Fusion in the 2D category, all the heights tab tend to stay the same. Now, when you're using more of a finish strategy versus rough, you get back your feed height. So again, as to give you guys a demonstration of that feed height, we're going to go ahead and hit no there because I need to give this a contour to work with. And as you're seeing is if I go ahead and fire off the ability to turn on toolpath points, this is going to be a little better way to understand where those layers are coming from. So again, let's go back to our heights tab. So looking at this, again, we have things based on, we'll start at the top this time. Retract is in orange. You have your stock top for the retract plus 200. That's going to be this green line. Our next height is going to be our feed top height or our stock top, right? So again, we're going to work off stock top plus 200. Well, what else is stock top and 200? Our retract height. So for demonstration purposes, again, I'm going to change and put 0.1. Now, this is very important for you guys to understand is by default, the finished toolpaths are trying to use the same retract and feed height. But if you notice by me changing that number, we've now generated that third line in there, which is a green, light green line for feet. So let's hit OK again and let's look at our points. So what's happening is we are starting and we are rapiding down, and then we are feeding down to a feed height. Then more than likely we're going down into our part to do our machining. So again, when it comes to our heights tab, we're dealing with finishing the walls down in the bottom of our pocket. What I'm going to do is I'm going to make a couple of changes. One, let's start by changing our top height to selection, right? And we're going to select that same height again. Now keep in mind, that's going to automatically move our feed height right now down. So again, had I changed my top height, the feed height moves, but my retract still stays up at the top. So this time, you'll notice this yellow line is now rapiding much further down into my part, and then I'm doing my 100th thou feed move, and then I'm going down into my part to make my cut. So again, when you're really looking to start squeezing cycle times and make things work to your advantage, this is where our heights tab can save us quite a bit. And I'm going to explain this a little bit better here is, had we not separated our feed height from our retract height, if your tool at the end of the day has a plunge feed rate of say 1 inch per minute, to get down 2 inches is going to take quite a bit of time. So again, another scenario here, we're making minimum changes. I wouldn't have actually needed to change my offset. I'm going to go ahead and reset my system default, but we can wrap it down to 200 above whatever our top height is. Now, you're somebody that likes to live a little more dangerous, or you know what you can get away with some years of experience, you might decrease your top height. I might also say that when it comes to retracting, I would like to jump top height again. And let's just say I want to stay 0.1 over top of that top height. So what you'll notice, again, we're going to have our clearance move. All of that stuff can be shifted so that we could just wrap it over very close to the part. This is a little more advanced procedure. Could cause you some problems, again, because going back in a third time around is I might need to separate that clearance height. So again, I think if it was me, model top is adequate, and let's stay within, 50 of the model top. And demonstration purposes here, guys, I'm going to add in a second chain so that we can verify that jumping from one location to another location, we're barely missing the top of our part. We are living dangerous, but we are shaving cycle time. So that is a big part of what you see here between those settings. So we're going to go ahead and shift things around a little bit because I'm going to go ahead and jump from the 2D. We'll take a real quick look at the bore side of things. Again, these are more finished strategies. So when we talk about bores, again, if you guys remember, or if you haven't caught the video yet, we need to define our geometry a specific way. And this is where we start to look at top heights being calculated different. I'm going to rotate a little bit here. As you guys can see, we are now working with whole top versus whole bottom. We can override this at any time by utilizing things like selected areas, or we can offset these. But what I want you to pay attention to is because we're using a cylinder, it is considered a hole. If our cylinder was to change to one of these tapers, same rule applies, right? So again, you have your whole top, you have your whole bottom. If you are finishing a wall before you're finishing the floor on something, you may want to account for whatever material is left at the bottom. So again, by shifting that up 20, you'll notice my last pass here above my head is 20 thou above that bottom height. Not common, but just another scenario to show you guys how you can use the heights tab to kind of filter down your toolpath more and more. Now, where the heights tab really does start to become powerful is, again, when you're dealing with those roughing and those finishing moves and trying to limit the number of step downs you make so that you're not cutting air. Will the board do a center of the hole? Will the board do the center of the hole? I would need a little more information on that, Paul. Again, today's video is mainly talking about the heights tab. If you guys have questions like this is why we offer the free support Fridays. And that would be a great time to ask that question. So we're going to shift things out. We're going to go ahead and jump over to 3D tab. This time around, I am going to do pocket clearing to kind of clear up a question somebody had before. Let's say I'm going to stick with that 2-inch shell mill. Geometry-wise, we're going to say none. And then lastly, we're going to leave our heights tab alone. But one thing I want you to look at is the heights tab is identical to the 2D area. However, when we get down to our bottom height area, we are now set to model bottom. And then you're going to notice we have an offset plugged in of 20 so that we can machine all the way down to our model bottom, but not past that, right? So again, this is one of those scenarios. I might want to plug in a negative here so that I could get down past the bottom. And then when we flip it over, we don't have to deal with the funkiness of the hat. Now I will need to drag this toolpath back up to the top because this toolpath does have what's called rest machining. Again, we talked about that on our last week video. Now I'm going to turn it off for this toolpath because the idea is still the same. As you guys are seeing, I want to start controlling things with the heights tab. I may want to do some different stuff in this toolpath, but from a default, 3D does tend to be extremely valuable to get a very efficient toolpath going in, machining around, and that nature. So let me get the points turned off. I turned the wrong thing off, but it all still works the same, right? So again, you have your clearance heights, things of that nature. I can jump over to the heights tab. This is a roughing toolpath, so we don't have a feed height anywhere hidden in here, but you could then manipulate further than here. So if I wanted to limit this toolpath by not going lower than a specific pocket, same rule kind of applies. I can do a selected surface. We're going to go ahead and select this surface here. Now, I may not want to go past that surface. So again, my offset is now 0. And as you guys are seeing is I am now limiting everything across this part to that one specific surface. So again, changing that one more time. And this is where we get into talking about toolpath efficiency, being able to use a stubby tool to go so deep, maybe go to a longer version of that tool to go even deeper. So again, as you're seeing, I'm not doing much with my heights tab because there's really not a lot that I need to do with that inside of 3D. If we switch to a little more of a 3D toolpath, again, I keep referencing last week's video because it will make all the difference in the world for a lot of you new to Fusion, is if I was to want to 3D this kind of feature on this part, and I go through and I say a selected boundary, and with that, we're going to go ahead and stop with our tool center on boundary. I just want to get a toolpath to show you. From here, I did a spiral toolpath for some reason. But notice right now, my heights tab is currently set to model bottom. So by changing anything I can here is never going to actually get that toolpath to go further out and around my part. So this is why it's so important to move left to right, top to bottom, because something as simple as, well, what if the tool was outside of that boundary? And now you'll notice we're going all over our place here. I am going to switch strategies here real quick, guys. Let's go back into a scallop toolpath. Select that boundary one more time. Tool outside. But what you're going to notice is that toolpath isn't going to work with a 2-inch shell mill. But if we get our 3/8 drill or 3/8 end mill out, is one, we are going all the way down and around our part. So we did luck out here that with adding that boundary, Fusion is still respecting that it can't go down this wall. However, we might be going too far one way or too far another way. So again, we could limit that in our heights tab. So again, you have what we like to say as the where location in X, Y, and then you have the where location in Z. So in this case, I may want to stop at a specific Z height. So let's go ahead and pull this edge here. And you'll notice that this will now trim our toolpath not to drop lower than that specific Z height. So again, as you guys are seeing here, I'm really forcing the toolpath to work backwards in this case, but it could be working to your advantage, or it could be remedying some of those problems that you guys see. So from there, we're going to go ahead and look at a few more other toolpaths. Now, this is where I would say we're going to actually pivot to drilling here in a moment, but I want to look at one more thing. So we will come back to something like the flat toolpath. Again, we're going to go ahead and do our 1/2 inch end mill. Notice here, once again, the settings are all basically the same. And this is a toolpath because we are 3D. It is model aware, and it's automatically finding anywhere and everywhere on our tool or on our part. But again, good example of this, we are dealing with a clearance height that is much larger. So we're always going back up to our, not our clearance height. I apologize, guys. We're always going back to our retract height. So again, this is one of those scenarios, and this is why that left to right works really good. We would have to go over and make some changes in our linking tab, which we will be doing in later video. So let's shift gears a little bit. Let's talk drilling one more time around. So in our drilling tab, when we want to go through and drill our holes, I'm going to make a example out of one of these. So let's say I'm going to go pick a drill bit if I have one in here. And it does not look that way. So we're going to go to our Fusion library, pick our drill bit. If you guys are wondering where your Fusion library is, go ahead and right click, turn all libraries on so you can see these tools. But let's say we're going to go in. If I remember, this is a metric part, but we're not going to abide by those rules. So let's just go like a 250 hole. So again, we have our aluminum drilling. And now I'm going to pick one of my holes to drill. I'm going to start with this guy right here. Now, when we look at our heights tab, what you're going to notice is, again, this looks very familiar, right? So we're dealing with a hole top to hole bottom. Well, it just so happens that is a through hole at the end of the day. So what I need to do is I want to make sure that we're going to say drill tip through bottom, which Fusion is now auto calculating our drill tip angle. So be aware if you're using a 118 or like a 130 or any kind of weird drill tip angle that your tool is defined properly. But then I can go through and I can actually give this a breakthrough amount. Now, this is going to be a little strange at first because, one, this background looks like it sucks. Two, I'm realizing I don't have my chat displayed for you guys. See all the questions that I'm answering. Give me a second, guys. I'm going to refresh my chat so you guys can see it here. Now you guys should be able to see the chat. And two, I'm going to go ahead and kick over to a different visual background. So bear your eyes here for a minute. We are going to go back to the photo booth because I think you'll see this blue color a little better. Now, again, as you're seeing, we are going from hole top. That does happen to be inside of what we would have spot drilled. But the idea behind the drill tip through bottom and breakthrough is we're automatically doing the math based on drill tip angle. Had we wanted to go in and guesstimate this, we would have had to say negative, let's say 150, to get our drill all the way through our part and then some additional. So I don't recommend doing an offset. I do highly recommend, though, is utilizing drill tip through bottom. Now, based on other holes on your part, you may or may not need to deal with what would be considered a drill tip at the bottom of a non-through hole. Doesn't look like I have any here. If you guys are wondering, if I click the flat on the bottom of these all have what's considered a modeled drill tip. So again, for demonstration purposes, we're going to go ahead and do a section analysis here. What that's going to allow us to do is to see the bottom of that hole. And one more time is if I go in and I do a drilling here, this is where instead of utilizing necessarily our geometry on this wall, I could add the geometry to the bottom as well. And what that will automatically do is bring our drill again all the way down to the bottom of whatever that hole face is. As you're seeing, it's automatically calculating to get me down there. If I wanted to from here, instead of using both the wall and the drill tip surface, I could easily go in, again, turn on drill tip through bottom. Notice how I'm getting different results. The reason for that is because the diameter of my drill does not match the diameter of this hole. But I'm just building out those scenarios again for you guys to understand and see different things that are going to happen. I am, however, going to say is, let's say we were going to drill several holes here. Again, we're going to go ahead and hit our OK button so that we can see that tool. Again, we just play the heights tab game all over again. This is where I'm going to change my visuals back. Apologize for anybody watching this late at night and you've just been blinded. But notice, again, that yellow, we are jumping up and over. Again, this is controllable to keep our tool down. So we'll go to our heights tab. In this case, we have our top height. Remember, we could change this guy to top height, bringing that down and being able to utilize it for what we need so that our tool isn't making a bunch of rapid retract. Now, you're going to notice there is a little bit of a dog leg in here because on some of these holes, we are starting below the countersink. So just keep that in mind that because those holes are starting down further, you would have that change in the outcome. Now, I'm going to go ahead and pause here for a moment and grab a drink, but I do want to put it out there as, guys, we are now going to shift gears into 4 and 5 axis type of clearancing, which is going to get a little wild. Now, in order to have some of these options, you are going to need the machining extension. Just a reminder, if you guys don't have it, you're looking to purchase it, or you want to move your licenses over, feel free to reach out to us here at JitCAD Cam. We are an Autodesk reseller and would love your business. So let's do this. Let's go ahead and shift gears here. I'm actually going to go to this flange, to which I've already done a setup for 4th axis. Again, XYZ location is very important. There's been some things added to Fusion that some people do or do not know, is we now have what would be referred to as multi-axis drilling. So again, this is one of the few times I'm going to do some multi-axis stuff. Don't worry, don't get too caught up in this, because what you're really looking to see and talk about is going to be when we look at setting our actual heights. We now have changed from utilizing a kind of Z-axis or plane only system into a cylinder system, right? So give me one more second here. We're going to go ahead and say same size diameter. And I'm going to hit OK. Of course, we need to give it a drill. But this is where our heights tab has completely changed. Now, this, again, can get you into a lot of trouble. Because if you notice right now, by default, we are not clearancing very high above our part. This is why our simulation is going to be very important. You may also notice right now, we are not going deep enough in our holes. So again, when we look at our heights tab, you're going to notice that by default, we have a clearance height based on our stock OD. We also have a retract looking at our feed. Our feed is looking at our top height. This is where it would, again, be very, very smart to think this out and play around with some of these options. See, I may want my retract height to actually be driven by my clearance height, or I may want to increase that to a specific kind of dimension. This is going to be either a good thing or a bad thing for a lot of you, but let's get down and do our drill tip through the bottom. I don't know what this is in millimeters, guys. Bear with me. I have no idea on the metric system. But again, the rule still applies. We have our drill tip through bottom and set up as such. So this will get you in trouble when you start to think about moving to a square part on the mill. So again, as if I do drill, and we're going to go ahead and do our 4th axis here for demonstration purposes. We're going to pick our hole. We're going to do the same size hole. And again, we have our cylinder in play. So let's go ahead and get our drill bit for this. Give her a second to calculate out. Now look at how these rapid moves are going to happen. Because if I was to simulate this, I'm going to give this a machine here because I think this will be valuable to see. Let's go ahead and throw this on the, I should have a UMC in here somewhere. That is a do not. So we're going to go ahead and switch gears. Actually, I should have UMC 1000. Probably going to have some problems with it because, again, you guys know we make changes to these models on our free support Fridays. But there's my part. There's my machine. Let's get reorientated. Of course, we got to recalculate here. And again, I can't stress this enough. This is what is so important about a good built machine simulation, is to ensure that you're not going to have these problems at the end of the day. We'll go ahead and flip around the other way. And we'll see the tool come down here in a minute. But there's our first drilling. And notice how close we are to our part. This is your first time ever doing something like this. I would assume you would be puckered up pretty tight. So again, I want you guys to be aware when you're looking at some of this stuff is those linking moves are very, very important. But what's also important at the end of the day is the axis driving those linking moves. So again, we're going to go ahead and we're going to go to our toolpath visibility, and I'm going to turn on tool axis because again, this is where we don't need to go all the way to simulation, but Fusion is telling us kind of which direction that tool is going to go. Bogdan says the operator just had a heart attack. Yeah, this is one of those scenarios that this is why I felt instead of going toolpath by toolpath, we're breaking down the tabs before we do that, because we do know that we can remedy this, again, going to our heights tab, and we do need to make those changes based on that. So again, some things that can happen is by changing our clearance height out further. As you notice, I'm grabbing that clearance and I'm dragging it much further out, and we can hit OK and see if we get a different result. As you're noticing, we're coming from further out. So this is another key element when we talk about changing up to the cylinder or sphere method, is our toolpath is now coming from the shortest distance from that boundary. So it wasn't necessarily clearance in this case. Our problem is actually going to be more around the fact that our retract heights are not far enough out. So again, I may need to change that to be, let's say, 1 inch. As you're going to notice is if I go to 1 inch, we're much further out when we start that swing. I could increase that even more. So again, let's say we're going to go 3 inches. And as you're noticing, and this is why it's so important, is that yellow line is us rapiding down, then starting our drill cycle, and then rapiding back up and spinning around our part. So that is the luxury of being able to independently control things like the retract height versus our feed height, right? So we retract, or we wrap it down and then feed into our part. So how would the bottom height work if you don't use the whole bottom? Scott's asking. So the bottom height would still work the same. You would do something as a selection. Now, I don't have selection in this case because in this current scenario, we are utilizing the multi-axis drilling. But I'll go ahead and pivot back here real quick. Let's go back to another part. So a good example of this would be is, let's say actually, I'm going to do this. This is going to be ugly, guys. You're going to have to bear with me because this part will work. We're going to get the analyze turned off real quick, and I am going to create a new setup. The setup's going to come from the backside, which would be the correct way to machine this first. But let's say I want to go ahead and machine this out. We're going to go ahead and say fixed size box. This would have been the first thing we did, right? When I do my drilling here and I pick my through holes, just going to go ahead and grab all of these, is if we are working with whole bottom, you're going to notice that on some of these we have a counter bore and we have a counter sink. Well, the problem would be is the overlap between them, right? So if I did drill tip through bottom and then thinking about it, I want to do not 0.5, let's go 0.05, is in the case of this hole in particular, is I'm not far enough through that when we flip our part, I can plunge into that. Same thing might apply as we're not deep enough right now to that bottom surface to punch through for working back the other way. So this is where instead of using whole bottom, I could use something like selection and I could pick that floor. Now we still get the ability to do drill tip through bottom as well as an offset. And again, for you guys, I apologize if you can't see this the best just because of the background. But now all of those drills are going to that specific depth. Again, the problem with this is when you start to deal with holes that are on different levels or different breakthroughs. That's why we tend to stick more with something like hole bottom and then utilizing a few other additional offsets if possible. Now, to remedy this problem, if you were, the big if, drilling through something that has a feature on the backside, this is why we would go back and actually add in those additional faces, right? So again, now you'll notice, we'll look at it upside down so I don't have to keep flipping it, making people motion sickness, is that whole bottom is merging that other segment all the way up and through. And again, I don't need to be in my heights tab messing around with things. That's why I'm going to explain this as the left to right, top to bottom, geometry. That is part of the whole geometry I want to drill from the backside. So I need to add that in here as well. So I hope that answers your question, Scott. We're going to go ahead and jump back to our 3+2 part. So again, that 3+2 part, as we went through, let's go ahead and do the old F6 move to figure out where our part is again, when we went ahead and adjusted our heights tab so that we can get away from our part quite a bit. Now, on a 5-axis, it's a little more forgiving because we are very much fixture and model aware. On a 4th axis is where you would get in trouble if you think about swinging a tombstone around, right? You may have parts on all sides of that tombstone as making sure your tool gets up high enough and clears the tombstone. So let's look at now a 5-axis scenario, right? So what I'm going to do is I'm going to go back in, I'm going to add, and again, I do this with drilling because drilling calculates very easy. However, it makes for quite interesting results because again, we're going to go 5-axis now. And with that, I'm going to drill basically the corners here, if it'll let me. So as you guys are going to see now, it will not allow me to do that because the clearance height must not be below the retract height. So when we go back and look at our heights tab, as you're noticing, again, our clearance height is causing the problem. So we're going to go ahead and pull that up a little bit. We're actually going to have to pull that up a lot of bit. But when we shifted back to 5-axis, we went back to a plane structure. And now we are getting some extremely different results again, right? So I want you guys to just pause for a moment. And when you think about this, is my tool based on that plane from tool orientation, right? So again, we're automatically orientating our tool where we could change this if we wanted. But each one of those tool paths are going to start from whatever that distance is on that plane. And simulating this, you'll notice, again, there's going to be quite a lot of pucker factor. Now, in this case, my machine does not have rewind. I knew we were going to get something along the way. So let's go ahead and fix that here because, again, you guys watch this video and then you have the same problems that we have here. Let's go ahead and edit our machine. And there's a couple of ways to remedy this, and I'll show you guys here in a moment. One is based on your kinematics tree for C-axis, you may be unlimited or cyclic, or in your multi-axis tab, we need to do the retract and reconfigure. So again, we're going to give this a real quick moment, and then we're going to do our simulation all over again. Give her one quick second. And now you can see we got our tool path back, and because of our moves here, here's our rapid over, rapid down. We come in, notice, this is, remember we set that plane from the top of our part, which is why we're rapiding over like that. You guys seeing this? This is going to be nothing but a good time when you try to run this part. So this is why we, again, we'll go back here. We're going to go ahead and hit play. We now went to our home position, came back in. We're kind of jumping all over the place when it comes to those rapids and retracts. Now, we could fix this. Man, it pisses me off when the machine is on. So let's go into our heights tab. So again, because we are now thinking in a 5-axis environment, we still have a cylinder. We also have a sphere. And lastly, we have a box. So again, every use case is going to be a little bit different. And as you guys have already seen with the cylinder works all right, but let's say we wanted to go with a box here. So again, we can change that box any way that we need it to be in our Z height kind of fashion. So again, we can increase or decrease whatever our Z height is. If yours truly can click the right thing. So as you're noticing, we could expand out that box. And what you're seeing is the clearance height was not high enough. Again, we got to go back. Hold on here. We got to make that even further. And what you guys are noticing with these errors, the problem is because we put in a ridiculous feed height. So let's say we went back to 1 inch. We could change that clearance to be much closer. But now these linking moves, again, very, very dangerously close to the part. So box may not be the cure to what we need. I'm going to go ahead and plug in 3 inches in that retract height. And now you notice we're still wrapping across very close to our part. So this time round, let's go ahead, instead of using a box, let's utilize a sphere. So a sphere, again, because we are 5-axis, we can use that sphere to also calculate the same type of scenario. So again, we're going to go ahead and increase this a little bit for the first time through and see if we can't get that toolpath to stay outside the sphere and jump into those locations. So again, kind of like cylinder, if you notice, I am now respecting the fact that I want to keep the tool away while rotating the part. So I've really had to spend a lot of my time in these cases up here in my clearance height and clearance geometry. Then I'm really going to have to spend down in my bottom height, right? So if you're used to 3-axis milling, we could simply say drill tip through bottom, use the old Fusion fill 50 thou. None of that's going to change. But when we go to simulate and run this at the machine, we're going to see that, again, we're going to get that tool away from whatever it's trying to do. Again, here we come in, we drill. Notice how nice that is to stay away from the part. And lastly, we'll come back in and get those last 2 holes. So nobody has to have a panic attack. Nobody has to be fearful of what is happening. But this is all now going to work the same kind of way if we look at some of our other toolpaths. So let's say, for example, another really good multi-axis toolpath is going to be the flat strategy. Again, we have 5-axis flat. From here, we're going to go ahead and utilize a different tool, of course. Let's grab, no, let's not do the 2 inch. We're going to do the 1/2 inch with the bowl. We're going to let the toolpath calculate out and do its own thing from the start. We're going to ignore the spindle speed because, again, guys, I grabbed a machine from the library. I'm grabbing random tooling. She might be a little spicy for what we're doing, which was that warning. But we'll give this a moment to calculate. Again, it's looking for everything between 0 and 120. But what I really want you guys to see is once we get that toolpath on the part, again, notice how close all of my toolpath is to physically that part. So again, due to things like fixture detection, which is why we get weird moves like this, that I feel like I'm beating a dead horse on you guys. Let me know in the chat if I am. But again, we have our avoid machine surfaces in 3D. We're avoiding the fixture in our geometry tab. But our heights tab, everything again is super close to our part. So if we went and tried to simulate this, again, we're going to get quite a bit of pucker factor at the end of the day. So we'll give this a few moments here, get rotated around like we have in the past. And as you're going to notice, we're going to get down there. We're going to start to do our flat areas, but we're not really getting that tool very far away from the machine. Now, this is really good in a production environment. Not so good when we start to talk about, you know, like that first article or scaring people at the machine, right? So again, as you guys are seeing, we're never really getting too far away from everything. And some of you are probably questioning some of these collisions. These collisions are being caused because we never actually roughed out the part. So we're just slamming the tool into stock right now. So again, we go back to our flat strategy. We may just simply jump to the sphere. The sphere in itself, we can increase or decrease depending on what we need. Again, you can adjust where it is on your part, and I'll show you some examples of why you'll want to do that here. But let's go ahead, recalculate. Again, we're going to ignore the spindle warning. But you'll notice this tool is now going to go out to what I would refer to as kind of a lollipop entry and exit, but it's going to be based on the closest area of the sphere. And we'll see that here. It's going to take a moment. Again, we're starting to deal with 5-axis craziness. And what I'm going to do is, again, if you kind of pay attention to more of the red lines on the outside, notice how spherically everything is getting up and away from that part based on that parameter, right? Now, a neat trick to this is, let's say, for example, I don't need it to go from center of my WCS at the top of my part. I can actually move that to somewhere else if I would like, right? So again, this is why you could say a selected point. It's going to be ugly. Bear with me. But let's say I go off the selected point down here at the bottom of my model. Now, I am going to increase my clearance and my retract a little bit. I will also show you guys that you have additional offsets now by using a selected point origin. So I could bring this back up 5 inches. And it may be a little tricky out there, but if you notice, my origin is now here, 5 inches above the bottom. So I could now customize or manipulate according to how I want. I think I'm going to go up just a hair further, just so that we get a little nicer kind of clearance, and it's a little closer to my part, but still adequately far enough away that we're not having nightmares and losing sleep. So with that, we're going to go ahead and let this calculate out one more time, but I do want to open it up to you guys. As if you guys have any questions at any time, feel free to throw them in the comments area down below. You could also put in support tickets to us directly using the support link down below. But again, as you guys can see, a little nicer toolpath. I am going to turn off some of these visibilities. So again, as you guys are going to see, is if I remove the tool axis, that yellow line definitely shows us when we're jumping from area to area. And we could simulate this on the machine, noticing that we're a little more forgiving now. Again, let's get rotated back around here so we could square up to the part and hit our play button. And again, as you guys can see, we just made that one jump up and over. We'll go ahead and pause it here before we go to the next one. So here's our secondary move right there. We're a couple inches away. I mean, I would feel adequately comfortable with that, just knowing that the machine isn't anywhere too close. Now, I've seen a couple of questions come through today. If you guys do have more questions or you want to see something in particular, feel free to shoot us an email with the link below, and we'd be happy to show that on our free support Friday. Now, I am going to remind you guys that we do have tomorrow is going to be Turning Tuesday, where we're covering kind of the same thing, but on the lathe, it's more the x-axis radii of the part. So I'm going to leave you guys with it. It's not what you know, it's who you know. You all know Fusion Phil over here at JitCAD Cam, and I'm looking forward to seeing you guys back here Tuesday as well as Friday to ask us those crazy questions, bring us your problems, see solutions that you may or may not have thought about. And with that, have a great rest of your day.